Hello, Mario! Maths Quiz 4. Engineering Maths Quiz 4. A review. So, in this video, I'm going to take a look at Maths Quiz 4 and go through the model answers and sort of make a few comments and see if we can get them sorted, any problems that we've got. So let's get the Maths Quiz up and get it into the big screen and we'll start going through it. So, question 1. Evaluate to 4 decimal places this log to the base 4, 0.2. Now, when I'm dealing with logs, I find, and this is what's easier for me, that logs follow a particular pattern. Now, because of when I first started doing maths at secondary school, calculators such as the one here on my right of the screen were not actually invented. Neither were the little simple 4-function add, multiply, subtract and divide. So we actually had to do our mathematics either by long division, multiplication, or using a little thing called a log book. And in the log book we had to look up the logs of numbers, and we had to put a number in front of them that indicated if they were to the power of 10, we'd put a 10. If they were to the power of 100, we'd put a 2. If they were in the thousands, we'd put a 3. And so on and so on. So I very quickly knew that log to the base 10 of 100 was 2. And log to the base 10 of 1,000 is 3. Log to the base 10 of 10 is 1. And so I have this little pattern that I write because I also know that 10 squared is 100. And this is the pattern of logs. And this comes about because of my experience that I had in my learning environment, that I happen to know this. But for those of you that don't have such a rich and lengthy experience, you will have to just remember it. So I just write this little pattern up there pretty much every time I do a log calculation. I write it up there, and that's my prompt. That's my little mnemonic, or whatever you want to call it, that enables me to work out these logs. So, looking at this example here, what we've got here is log to the base 4, 0.2 equals x. Now, if we follow the pattern there that I have got, there is another pattern, of course, on your formula sheet, which would be log to the base a of x equals b, or something like that. And you can follow that pattern equally as well, so that a to the b equals x, or something like that. So it's quite easy to follow. So just following my pattern, though, I can see that the base, the 4, goes where the 10 is. It's the 10. And the x is the 0.2. And the x, yes, is the 0.2. And the x in my little calculation here is the power, or the index. So log to the base 4 of x equals 0.2. And so that's I've got that far. Now, so that's log to the base 4. Now, there's also, just remember that on your formula sheet, you've got this little thing over here, which is also, this is another way of doing it. But straight up, this is the way that I did it. And then I took the log of both sides, log to the base 10 of both sides, like so. And then I could say, well, x equals log to the base 10, log to the base 10 of 4 equals log to the base 10, 0.2. and then I can divide through by log to the base 10 of 4, and I get x equals log to the base 10, 0.2 over log to the base 10 of 4. All right, so that's just working through from my little pattern there. Now we can also get to the same sort of place here by using this little pattern here, and as you can see, log to the base b of x, where b can be any base, equals log to the base a of x over the log to the base a of b. All right, so looking at what we've got here, using log to the base 4, 0.2, we can see that b is 4. So we're going to have log to the base a of 4. And the base that we're going to use is the known base of 10. So we're going to have log to the base 10 of 4 over log to the base 10 of x, which is, in our example here, 0.2, which is exactly what I got using this method here, incidentally. So, yes, there's quite a little detail in that. So you can either come down this line here, or you can use this little pattern or template or pattern as it appears on your formula sheet, from your formula sheet. So really in a test situation that might be the easiest one to use, but this one here I memorize it through. All right, so now it comes to the point of working it out. So let's work it out now. So we'll go to the calculator, and so we're going to go log to the base 10 is this one here, log 0.2, close the brackets, divided by log of 4, close the brackets, equals. And there we get 1.6096447. And it says that it wanted it to 4 decimal places. So if we go shift setup, fix is 6, and we say 4 decimal places, we get, oh, and don't forget the negative. Don't forget the negative. Negative 1.610, 4 decimal places. And I must, it's very, in mathematics, we write the 4 decimal places. We write that in there. And it's very important, I guess, that you do write that in there so that we know that this is rounded, and so that we know that it's not exactly that value, it's a rounded value that is approximately that. So there's some people go so far as to put a little couple of wiggly lines in there to say that's approximately equal to. But I tend to favour using the equals sign. So there we go. That's that one all sorted. Now this next one, solve for x to, and note that it's to 3 significant places. So 4 decimal places. Just note that each one's showing that. So 3 decimal places. 5, 3x plus 1 equals 10. So let's take the log of both sides. That's how we get or devolve backwards from the power. So we can take the log of both sides and everything's good. So log to the base 10 of 5 to the 3x plus 1 equals log to the base 10 of 10. So now we can divide through by log to the base 10 of 5. That's what I've said here, divide through. And you'll see obviously that dividing through by that, you are going to get here log to the base 10 of 5 there, that's going to give you 3x plus 1, and you're going to get log to the base 10 divided by log to the base 5. And now I'm going to continue just to get, we want to get all the x's on one side, so, and without the numbers, so I'm going to divide through by -1, so I get 3x plus 1 log to the base 10 of 5 gives me 3x log to the base 10 of 10 over log to the base 10 of 5 minus 1. Okay, minus 1. And then I've got 3x. I'm going to divide through by 3. And that gives me x equals log to the base 10 of 10 over log to the base 10 of 5. Okay, minus 1 times a third, or divided by I've got it there. There's the thing, and I can change that to times a third. So now we're going to get our little calculator up and have a look at that one. So, all right, so that's divided by 3 is the same as multiplying the top by a third. Okay, all right, so let's get our calculator out. So first of all, we're going to go log to the base 10 of 10, close the brackets, and that's, if we just, out of interest, I'm just going to go equals there, that's equal to 1. Okay, log to the base 10 of 10 is equal to 1. Alrighty, then we're going to go divided by log to the base 10 of 5, close the brackets, equals 1.4307. And then I'm going to subtract 1 from that, and then I'm going to, I could either divide by 3, which is or multiply by a third. I can go times 1 divided by 3, which is a third, equals, and we get 1.436, but we want that to 3 significant figures, which, now remember that with significant figures, it's the first non-zero digit that is significant. So the first significant figure is the 1, the second one is the 4, and then this is the third one here, and we're going to round to that. So we can go shift set up, fix. I don't know whether we can do significant figures with this. Fix, which is 6, and then we'll go to 3, and oops, not divided by 3. It came out as 0.144. Oh, perhaps I need to, can't go back, so I'll just go, I'll quickly do it again. Log 10, close the bracket, divided by log 5, close the bracket, equals minus 1 equals divide 3 equals 0.144 to 3 significant figures. And it's important that you show the 3 significant figures. All right, so next we're going to go page down. And so here we have question 3 up on the board here. This is the hardest of the 3 questions at the end of the test. So as with exams, a bit of exam strategy, that the questions usually get harder as you go through. So if you're in a test or an exam, it's probably not a bad idea to go through and get all the easy marks first. You don't want to be left at the end with a whole lot of questions you can answer but no time to answer them. So you do need to prioritize and strategize your way through the exam. Some people have little bits of information that they write down as soon as they get inside the exam, and like with my little pattern with the logs, and they write that as soon as they're able by the various questions. Anyhow, here we go here, just some little information from the formula sheet, and I'm just going to drag up the formula sheet here for us now, and we can see that we've got some of the log information that we've got. So we've got the exponents and logarithms, and here's the log. So here's the little log pattern that I told you about earlier in the earlier questions here, and here's that. Now there's one. Where did I get the one for the changing of the base? Oh, here it is here, the base change. So that was the little question in the earlier question. And some ones relevant to this one here. Log to the base a of a equals 1. So log to the base a of a equals 1. Now ln means log to the base e. So log to the base e of e is equal to 1. Okay, and yes, so that's the log to the base e of e equals 1. And so it's very important that you, there's sort of 4 pages of formula sheets. So be very aware of what's on there, and have this alongside you at all times when you're doing exam questions, so that you know and become familiar with what's on it. I'm just going to drop that out of there now, just for now. Okay, so let's look at this question here. And we've got I, we want to make I, current I in a circuit with resistance and induction can be calculated using this formula. And we've got I equals V over R, brackets 1 minus e to the negative r over t. So just be very careful, make sure that is a negative, and yeah, it's quite clear. Well, clearish. So I'm not going to go into step-by-step detail because I'd run out of paper here. So first thing when looking at this is we've got a multiply on that side. R and V, we're trying to get make L the subject of the formula, which is down in here. It's on its own, it's in that power. So we need to get everything else onto the other side before we start. So what I was going to do is I'm going to multiply by R, which gets rid of the fractional part of R, and divide by V, which gets rid of or moves the V over to the other side. So very quickly we get I times R divided by V. We can remove the brackets. That equals 1 minus e to the negative RT over L. So then the next thing to do is to subtract negative 1. And that gives you IR over V minus 1 equals negative e to the negative RT over L. Now I don't like those negative things there with the e and that. It just makes it difficult. So I'm going to multiply by negative 1 just to get rid of that. So that changes the sign of everything on the left-hand side and gets rid of the negative on the right-hand side. Just the negative in front of the e. So I get 1 minus IR over V. 1 minus IR over V equals e to the negative RT over L right here. Okay. So now we've got the L in a function on its own with the R and T admittedly, but on its own. So what we do is we take the log of both sides and we take the natural logarithm. Because we're dealing with e's, we take the natural logarithm. So we've got ln, and then I'm going to put a big bracket around that whole thing there, equals negative RT over L ln E. Now, this is where this little beauty here comes into play. ln E is 1. So we can effectively just sort of get rid of that, really. Yeah, we could sort of just pop that out of the way. That's just going to get rid of it. Okay, and so what we end up with then is ln 1 minus IR over V equals negative RT over L. Now L is what we're looking for. This is what we're looking for. This is the key point in here. Oh, it doesn't like text. That great idea didn't work. Okay, so this, we have to draw a line. This little L here, this is the one, this is the little beauty that we're after. Okay, so, and that's on the bottom. Well, here it is here again, on the bottom again. So, but we want to get it on its own on one side. So, well, first of all, what I did was divided by negative r over t. All right, so that that gets rid of the negative on that side as well. So we end up with a negative again. So dividing by negative r over t turns this into 1. So we get ln brackets 1 minus ir over v brackets over negative rt equals 1 over l. So 1 over l, we want l. So all we do is just flip it up. So we get L equals negative RT over ln bracket 1 minus negative IR over V. And that's our answer. That's the answer that we want. And yeah, all very good. Substitution and rearranging of equations. And there's quite a lot of that in this course. So you need to practice, practice, practice. Now, as part of this little exercise, I've been through and marked them, and I had a few little issues, which I've talked about a little bit here. Some key things. Show your rounding. And that's a lot of people, the question says 3 decimal places, 3 significant figures, ask you to do that. So it's testing you for rounding. That's part of the assessment. And so if you round incorrectly or you don't round at all, you will be missing out on some marks. The question tells you that it wants you to round them, so that's what you must do. Otherwise, even though you've got the right answer to 27 decimal places, but you've got the right answer, the examiner is asking you to round it to a specific amount, and that you must do, and then you must write that up, say that you have done that as well. All part of it, just to make sure you get the full marks. I talked a little bit about the strategy of just writing, going through when you've had your reading time, perhaps going through and writing a few little key mnemonics, like your Sokotoa, or your, just your little pattern that you might know, and that sort of thing. Always a good idea to put your name on the test. That way you're going to get the marks, because if you don't put your name on the test, nobody will know who did the test. Pretty simple. Always check you put your name on the test. And usually a lot of examiners and things will let you put your name on the test before the test starts or the exam starts. Or generally they'll go around and check, but good habit to get into. And note, with significant figures, the first non-zero digit is the first significant figure. So in the example we had 0.144. Some people put as their answer 0.014. The 0 is not significant. It's the first non-zero digit is significant. So there we are. That brings us to the end of my review of Engineering Test Quiz 4. And some of you did pretty well. Some of you have upped your game. But the key factor that I've got out of it, I'll get my black background in. The key factor that I get out of it is that those that practice and prepare and have lots of experience doing similar questions seem to do very well. So it's very much related to the amount of work you put in beforehand. And I've seen some people up their game from week to week because they've got a bit of a shock and realised that, well, perhaps I don't quite know so much of this stuff, and put a bit of effort in, and there's been a marked improvement in their performance and their things. And the other key thing is that if you don't know and you need help, you've got to ask. It's just not going to happen overnight magically. You have to come and ask for help and get lots of experience and do lots of examples. So let's hope we've got coming up at some time soon, we will have quiz 5. And let's hope that based on the experience of quizzes 1 to 4, that you might be able to up your game and improve your score. Cheers! See you!